Okay, so we're starting our final unit, and we're gonna split up into two parts here. So this first packet is just in preparation for our quiz, which we're gonna have next Thursday before break, and then after break we'll work on completing. I'll give you the second part. Which is applications of trig derivatives, and we'll have that test the week before that final week. So let me just kind of go through our schedule here. I think today we're going to just focus mainly on unit circle and solving trig equations. If we can get the trig derivatives, that's fine. If we can't, then we can pick that up tomorrow. So but our main focus is just getting working on trig derivatives. So we'll have tomorrow and Friday to begin reviewing for your we'll learn the derivatives first, and we'll practice go through our practice worksheets, and yeah, we'll have Monday to review as well, and then Tuesday we'll have 4 days to review. I'm going to start a little bit with curve sketching on Tuesday, but Wednesday be senior service day. So if you're here, it'll just be a study hall for you. But for seniors, won't be here in class. And then Thursday will be your trig derivatives quiz. I have more review worksheets than what we have time in class to do. So I'll have a couple of help sessions. I'll have a help session on Monday, and I'll have a help session on Thursday morning, in preparation for the quiz. Okay, and the quiz will be the similar length to what you see in the reviews, just be front and back. After that, after the quiz, we'll continue looking at curve sketching. Then we'll have Thanksgiving break. We'll come back and finish up with curve sketching and talk about related rates, inverse trig derivatives. So really, the test is just trig derivatives plus curve sketching, related rates, and inverse trig derivatives. These are the last set of derivative rules we have to learn. And then we're going to have multiple days to do our test review. I think on your calendar, I had the trig test on the 10th, but I'm going to move it to the 9th here. And the reason why is because admin wants these days to be specifically for subject areas. So 10th, I think there's 2 subject areas, 11th and 12th is math. But I want to have the test here just because we're kind of working our way to preparing for the test. We have 4 days. That should be enough to prepare for our test. And then on Friday, we're going to have trig derivatives, a rules and theorems quiz. And this will be an easy grade because we'll have Wednesday and Thursday to review it. It is just front and back of formulas and rules. And, most everyone gets A or 100 on this. So this should be easy quiz grade. Yeah.
For the trig unit test, there's none of the what we just did on quiz.
Right. So it's a completely different unit. Yeah. So no, our logs, we're done with the logs unit. This will just be focused on just trig. Yeah. So make a slight adjustment in your calendar. These dates have been changed, but we still have plenty of days to prepare. So test on the 9th, and then 10th and 11th, we'll do review for the rules quiz, but then I also want us to spend time looking back and doing some review from our packet, from our first semester review packet. And then the final week is just, these are full school days, but these are just gonna be makeup days. And then Wednesday through Friday will just be half days. These are not gonna be required attendance, but just for any students who need to make up anything across their classes, they can show up between 8 and 12 to make up any quiz or test or recoveries. All right, so that takes us to the end of the school year. Oh, sorry, of the first semester. Okay. Any questions? Oh, I do want to point out that the test will be with calculator, but the quiz next Thursday will be non-calculator. Okay, so non-calculator for this quiz. Okay, inside cover. Just want to highlight things that we need to know, and also crossing out the ones that we don't have to worry about too much. So right triangle, SOHCAHTOA, make sure we know our relationships for sine, cosine, tangent, cosecant, secant, and cotangents. SOHCAHTOA, we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We can also think of tangent as sine over cosine. That's also something that's good to know. And then cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent, but you can also think of it as cosine over sine. Pythagorean identities. The important one is sine squared plus cosine squared equals 1. There are two other ones. 1 plus cotangent squared equals cosecant squared. Tangent squared plus 1 equals secant squared, but you don't have to memorize these. You can derive them by dividing this original Pythagorean identity by sine squared. If you divide everything by sine squared, it'll turn itself into 1 plus cotangent squared equals cosecant squared. If you divide all this by cosine squared, you're going to get 1 plus tangent squared equals secant squared. Sorry, tangent squared plus 1 equals secant squared, yeah. Don't have to worry about the double angle unit circle values. We need to know that. So we're going to do some practice on the next page. And then no need to worry about graphing our trig functions. We'll get to use our calculator for that. Okay, so we need to review our unit circle values, but the most important thing is the first quadrant, because once you have your values for the first quadrant, you're just taking those values and moving them over to the second, third, and fourth quadrant. On the quiz and on the test, I'm not going to give you a blank unit circle, because they won't provide that for you on the AP exam either. But I will, if you want a scratch sheet, I can give you a scratch sheet. You can create your own unit circle from that. Okay. And also, we're not so concerned about degrees. What we're concerned about is radian. So we want to make sure that we're good with our radian measures and we're good with our unit circle. So let's work on first quadrant first. So we have the 0 or 2 pi, depending on if we're going all the way around the circle here. Here we have pi over 2. And then the important ones here are pi over 6, pi over 4, pi over 3. They all come with order pairs. And think of order pairs as x and y, but then think of x as your cosine and think of y as your sine. If you have trouble remembering the order of these, then just think alphabetical. C comes before S, so cosine followed by sine. Now, all your order pairs here, the way that I remember it is I know that all my order pairs have a 2 in the denominator. And I'm starting at the upper left corner, and I'm just counting from 1 to 3. So 1, 2, 3, and then go back up the unit circle here. 1, 2, 3. All your numerators gets the square roots, even the 1, but we know square root of 1 is just 1, so I'm just going to leave that square root out. So I'm just going to do root 3, root 2, and root 3. So now we know that cosine of pi over 3 is 1/2. Sine of pi over 4 will be root 2 over 2. Cosine of pi over 6 will be root 3 over 2. So this is the most important one because all these ordered pairs will be basically repeated across all the 4 quadrants, just with the signs may be different, but they're all going to be essentially the same. Okay, so now let's move on to the remaining of the unit circle here. Let me just start off by filling out all the radian measures. And if you're having trouble remembering the radian measures, let me review that with you. So here we're starting off with 0. Then we have pi over 2. Then we have pi, and then 3 pi over 2. Okay. The order pairs here are imagining you're just moving 1 unit to the left, and you're just moving along your coordinate plane. Well, this is 0 and 2 pi. But this order pair would be 1, 0. This order pair will be 0, 1. This one would be -1, 0. This one will be 0, -1. All right, so we know this is pi over 6, pi over 4, pi over 3. Okay, so to fill out the rest of the unit circle, let's start with the radian measures first. Basically, anything that is closest to the x-axis will all have a 6 in the denominator. Anything in the middle will all have 4 in the denominators. Anything that's furthest away from the x-axis will all have 3s in the denominator. So these are all, I'm going to highlight all the ones that are related. So we know that this is going to be something over 6. We know this is something over 4. We know this is something over 3. So the numerators, the nice thing about the patterns of the numerators is that it's always in the second quadrant, everything is going to be 1 less than their denominator. So what's 1 less than 3? 2. So 2 pi over 3. What's 1 less than 4? 3. What's 1 less than 6? 5 pi over 6. Okay. And then in the third quadrant, same thing. Closest to the x-axis is over 6. Middle is 4. Furthest away is 3. But now all these are going to be greater than pi. So greater than pi means that your numerator is going to be more than your denominator. And it's going to be exactly 1 more than denominator. What's 1 more than 6? 7. So 7 pi over 6. What's 1 more than 5? Sorry, 1 more than 4? 5, right? What's 1 more than 4? 3. It's 4. And then in the fourth quadrant, again, furthest away is over 3. Middle is 4. Closest is over 6. Now we know that we're getting close to 2 pi here, right? We're getting close to 2 pi, so we're basically all doubling, but not quite. So this is going to be almost double, but it's going to be less than that. So to find these numerators or remember these numerators, just know that it is going to be double the denominator, but then we're going to back off a little bit. So what's double 6? 12. And if you subtract 1, we're going to get that 11 pi over 6. Okay. What happens if I double 4? Okay, back off a little bit, we get 7 pi over 4. If I double 3, get 6, back off a little bit, I get 5 pi over 3. Okay. So again, we're not really worried about degrees, so I'm not going to worry about filling the degrees. The more important thing is just knowing our radian measures. Okay. Anything in the second quadrant is going to have a x value of negative and a y value of positive. Anything in the third quadrant is going to have negative x, negative y. Anything in the fourth quadrant is going to have a positive x, negative y. So we're really just going to translate that all across this. So basically, anything with the 6 in the denominator will have these numerical order pairs, just with a negative x value. Anything in the third quadrant with a 4 in the denominator will have the same numerical order pair. It's just that both your x and y values will be negative. Right, so see if you can just practice filling out the rest of the unit circle. And really, we're just repeating these numerical values over and over again, and then just making sure that we're assigning the correct signs based off of which quadrant we're in. Responsive. Okay, if you need any more support with unit circle, I can be available tomorrow morning to help you go through your unit circle values. This is also helpful if we want to find tangent and cotangents. So for instance, if I want to find, let's say, cosecant of pi over 3, I know that cosecant is related to sine. Sine is the y value, so I'm going to just take that y value and just flip it, make it 2 over root 3. Okay. If I want to do, let's say, cotangent of pi over 6, we know cotangent is cosine over sine. Cosine is the x, sine is the y. So if you divide these two, the easy way to divide them without having to do complex fractions is, the denominators will just cancel each other out. So just cover up the denominators and just divide the x over y. So root 3 over 1. So if you're ever dividing for cotangent or tangent, you know that your denominators will cancel out. So if you just cover up the denominators and just divide one over each other, then that could be a little faster. Okay, so let's spend some time practicing solving trig equations. We're going to work through this page, and if you're working ahead of me, that's fine. You can just check your progress, but the fact I have the key on page 4. All right, so starting off with 31. Just trying to get sine squared by itself. Take the square root. Plus or minus 1 over root 2 is same thing as root 2 over 2. If you rationalize the denominator, just so you can see that, oh, this is talking about that pi over 4 family. So sine is going to be, I just cleaned it up here. 1 over root 2 is same thing as root 2 over 2 if I multiply the top and bottom by root 2.
All right.
So 1 over root 2 times root 2 over root 2. So we know if you look at your unit circle values, it's going to be in that pi over 4 family. So anything, all 4 quadrants will be represented. So we just list out all the pi over 4s across all the quadrants. Okay, tangent squared theta equals 3. Solve for tangent. We're looking for plus or minus root 3 for tangent. So root 3, we know that tangent is sine over cosine or y over x. So we're looking for root 3. Root 3 will be in that power of 3, right? Root 3 over 1 is root 3, not 1 over root 3. So it's going to be in that power of 3 family. It's plus or minus, so we can list out all the 4 quadrants in that power of 3 family. Okay, 33, we can take out a GCF of tangent. Factor. Once we have factor form, once we have 0 on the other side, we can set both equal to 0 separately and look for theta independently. Okay, so tangent of theta is equal to 1. That means where sine and cosine are going to cancel out to be 1. And we know that's going to be in that power of 4 family because we know sine and cosine are the same. So we know that if we divide them by each other, we're either getting 1 or negative 1, depending on what the signs are. So tangent is going to be positive in the first and third quadrant. Oh, and also there's this acronym here, ACTS. And I use this to help remind us where which trig functions are positive where. So A is all. That means all your trig functions, all 6 are going to be positive here. Second quadrant, only cosine and its reciprocal, cosine and secant are positive here. Everything else is going to be negative. Third quadrant, only tangent and cotangent are positive here. Everywhere else is going to be negative. Fourth quadrant, only sine and cosecant are positive. Everything else is negative. So tangent is going to be positive in the first and third quadrant. So in that power of 4 family, so power of 4 and 5 power of 4. All right, tangent is equal to 0. So tangent is equal to 0 at 0 and pi. Because tangent is sine over cosine or y over x. So we're looking for something that will give us 0. So 0 over negative 1 or 0 over 1 gives us 0. And this is not going to work, right? For tangent, 1 over 0 would be undefined. So it's only going to be 0 at 0 and pi. The reason that we don't include 2 pi is because it's not part of our domain. So just 0 at pi. Okay, 34. We can't factor and set equal to 1. We got to get that 1 over to the left. We can't set the factored form equal to. Remember, this has to be a 0 if we want to solve and go through a factoring process. So we got to bring everything over to one side. Now this is going to require factoring, okay, trinomial factoring. If you don't want to do it in this form, you can maybe do an easier version of this problem if you want. Do this, factor this. And once you get this factor, then bring your cosine if you find that to be easier. So here, my factoring would be 2x plus 1, x minus 1. And if you can get that into factored form, then bring back your original variable cosine. And then go ahead and set both equal to 0 and solve. So we're looking for where cosine is equal to -1/2. We know 1/2, that's going to be in that power over 3 family, but cosine it will be negative in the third and fourth quadrant. So power over 3 family in the third and fourth quadrant. Oh, I'm sorry, I got these mixed up. ASTC. Sorry, sine is positive in the second quadrant. Okay. So second and third quadrant is where cosine is going to be negative. Cosine is equal to 1. When theta is 0 or 2 pi, or just 0. $35. Let's bring everything over to one side so we can take out GCF. So I like to think in terms of sine just because it's easier to think in terms of sine and cosine than this reciprocal. So if I flip this, if I flip cosecant, it becomes sine. But if I flip 0, I get 1 over 0. And we know sine is never going to be equal to undefined. So this, we have no solution. Here, secant of theta is equal to 2. If I flip both, flip secant, I get cosine. Flip 2, I get 1/2. I like to think in terms of cosine rather than secant, and this feels easier for me to interpret. So first and fourth quadrants in that pi over 3 family. Where is sine equal to cosine? Right? If you look at order pair, where is sine equal to cosine? We see that your x and y values are the same in that pi over 4 family, right? So be pi over 4 and 5 pi over 4. Okay, we'll skip 38, but we'll finish with 37 here. Cosine squared plus sine theta equals 1. It's easier if I can get it down to just, because it's not easy to factor this. There's too many different parts here. So what if I can convert that cosine in terms of sine? Well, we know that sine squared plus cosine squared equals 1. So if I can get cosine in terms of sine, then I'm able to get everything down to one trig function. So cosine squared theta is equal to 1 minus sine squared theta. So if I make that substitution, I can at least get it down to one trig function. And I can think about factoring after this. Bring everything over to one side. The ones cancel out. I'm just going to rearrange it, having that sine squared to be second so that my first term can be positive. Factor out the sine. So where sine is equal to 0, sine is equal to 0 at 0 and pi. Sine is equal to 1 at pi over 2. Okay, so really that's all the pre-calc trig review that we need to be able to do. We have time, so I think we can just go ahead and start looking at derivatives. All right, go to page 5. Does anybody still need look at page 3? Page 5. So we're going to start off with the two basic rules here. Sine's derivative is just cosine. So basically, if I want to find out the slope behavior of my sine curve, I can just look at cosine. Cosine will tell me exactly the slope behavior of my sine curve or sine value. And then cosine's derivative is just negative sine. So think of these as kind of like the parent functions here. And these are, amongst the trig derivatives, these are the most important ones. These are the ones that are most likely to show up on the AP exams if you see trig derivatives. So we also need to know trig derivatives for tangent, cotangent, secant, and cosecant. But before, I had students kind of go through product and quotient rule and chain rule to build the derivatives. But ultimately, you're not going to want to derive each of the derivatives. You want to be able to just memorize it and be able to have it accessible. So I'm going to skip this process for now and just have us work on building a form that we can look at patterns and make it easier to memorize these 6 rules. So I'm going to use the space here next to example 2. Example 2 is not going to require a whole lot of space. So I want to use this space to bottom corner to kind of organize these functions in specific ways so that you can have an easier time memorizing all these derivatives. Okay, and I'm also going to write the rules with chain rule built into it. So we're going to have them all written as sine of u or cosine of u, just like how we did with the previous rules, like log base a of u or e to the u. All of the u formulas are just built in chain rules. I think that's the more helpful formula to memorize. So what I want you to do is I want you to write down 2 columns. So 1, 2, 3, down the first column, and then 4, 5, 6. All right, so we're going to do derivative of sine of u for number one. Across from sine, you're going to put cosine. Under sine, you're going to put tangent. Across from tangent, you're going to put cotangent. And then the last row are the least commonly used ones, which is cosecant and secant. But we'll do secant first here. So secant. And then cosecant. So the left column, sine, tangent, secant, from most familiar to least familiar. And then for 4, 5, 6, you're going to put all the C functions in alphabetical order within these abbreviations. So COS, COT, and CSC. Okay. Cosine, cotangent, cosecant. We're talking a little bit about what this is going to help us with in terms of the derivatives. Okay. But let's write out the derivative rules in terms of u here. So sine is going to be cosine of u times u prime. We're going to memorize the rules with chain rules built in because this is the more helpful form for most of our problems. All right. Cosine is going to have a similar form to the one to the left. Cosine will be a negative sine of u times u prime. Tangent's derivative is going to be, well, tangent and secant will involve each other. And then you're going to see cotangent and cosecant will involve each other as well. So tangent's derivative is secant squared u times u prime. So it's going to take the one below and square it. And cotangent is going to do a copycat. It's going to do the same thing. It's going to look at the one below it and square that as well. But it's going to be negative. So negative cosecant squared u times u prime. Finally, your secant's derivative is going to be involving itself and the one above it. So secant is secant u tangent u times u prime. And then cosecant will do a copycat as well. It'll look at itself and look at the one above it, but it's negative. So negative cosecant u cotangent u times u prime. And what do you think is, what's nice about all these trig functions here? They all produce what? All the C functions will produce negatives. So that's a nice way to kind of keep track of your negative derivatives. And a couple of patterns to help you memorize these formulas. The ones across from each other will have the same form, right? A single trig function, a trig function squared, multiple trig functions multiplied together, trig functions multiplied together. And then tangent and secant are just involving each other for their derivatives. Cotangent and cosecant are just involving each other for their derivatives. Okay, so hopefully across all these different patterns, it'll make it easier for us to eventually memorize these rules. And so I really suggest that that we practice writing our rules this way, and also on the quiz to write these rules down as well. Eventually, I think this is a good thing to write when we get our non-calculator portion of our AP exam multiple choice, because these are the rules that will most likely show up on the multiple choice non-calculator section. And the nice thing about these rules that we'll talk about next semester is that I know these only like 6 rules to you, but these are actually 12 rules, because when we talk about second semester integrals, we're just moving backwards from our derivative rules. So the integral of cosine will be sine. The integral of secant squared will be tangent. So these rules, it's worth writing them out on the AP exam, because there's 12 rules that you can reference when you need it. So so this will come in handy next semester as well as we work on our antiderivative rules. All right, so let's look at number 2 and see if we can apply one of these rules here. So y equals sine of 5x. This matches nicely with sine of u. So now let's find y prime. So following the rule, what's sine of 5x going to turn into? Cosine of 5x times, wait, just 5, right? Yeah. Now, if it was x to the 5th, then it'll be 5x to the 4th, but it's just 5x, it's a linear, so just times 5. I want to keep reminding us that this 5 is outside of the 5x. These are not compatible. So I like to put the coefficient out in front so I don't get confused. I don't multiply them accidentally. But you can leave that 5 there. It's not an issue, but I just prefer to have my coefficient in front. But if you don't move it, you won't lose any points. That's my preference. Okay, so we'll just spend a few minutes just practicing these rules. So let's go to next page. Now we're going to discover that with trig, we're going to have some potentially nested chain rule involved. So let's look at example 3. Now that square roots, we want to get into a different form here so we can kind of see things more clearly. How can I rewrite this?
Cosine x squared to the 1/2.
Okay, cosine x squared to the 1/2. I'm going to put a bracket here. You don't have to. I should like to have a bracket so that I can differentiate it between the parentheses. So I want us to see that, okay, there's a nested portion here. I have cosine here, but there's an outside function, parentheses to the 1/2. I have to go through chain rule first, right? Outside times inside's derivative. So there's going to be chain rule involved. So let's identify the outside portion. And then we can worry about the inside later. All right, outside first. What's the outside's derivative? Power rule, right? What do we get? 1/2 raised to the negative 1/2. What goes inside here? That's what? Yeah, we don't change anything, right? We're not ready for the inside yet. Times, okay, inside, remember the derivative for cosine is negative sine u times u prime. So how do we apply that? Yep. Times good. 2x. Okay. Outside's derivative times inside's derivative. As far as cleanup goes, we're just going to push that negative exponent back down to the denominator and everything else. I mean, I'm going to do a little bit of cleanup here. I'm going to cancel the 2's out, 2 in the numerator, 2 in the denominator. I'm going to write it this way here. The negative sine x squared and x will stay in the numerator.
Wait, does the quiz work? This quiz work the same as last quiz?
Yeah, if you don't reduce, it's fine. But so even though I won't take off any points for not reducing, I do want us to practice reducing just because, later on when you're doing multiple choice AP exam, typically your answers will be reduced. So it's good to at least know how to get to the reduced, even if you choose not to do it on the quiz. Yes. Sure. Square root. Yep, you can move back to square root. It's up to you. Yeah. So 1/2 or square root are interchangeable. Yeah. Okay, number 4. What should we do first? Yeah, take out that 1/3. Yeah. And again, what's involved with this problem? Chain rule. Yep, there is. outside, inside that we have to resolve. And as a reminder, the derivative for tangent of u is secant squared u times u prime. So see if you can follow the same pattern as number 3 and build out your derivative using chain rule. Okay, it's not hard, it's just a little cumbersome with all of these parts, but we're just following our rules step by step here. Okay, no homework today. We'll have plenty of time to go through our worksheets, our review worksheets, but we're basically already beginning our review for the quiz. We're just working through all these derivative rules. Yeah. Yeah, you can, if you have a 3, you can reduce further if you like. All right, thanks, guys. See you tomorrow. Thank you.
Thank you.
Hi, see you. Hi.
Good morning, students.
No, yeah, it's for you. Wait, hold on, say it again?
You want Jackson?
Oh, yeah, sorry, yeah.
Flag, the United States of America.
Thank you.
Good republic, which stands one nation, under God, indivisible, with liberty and justice for all. Please pause for a moment of quiet reflection.
What was you gonna ask a question? Was this sure? Or no, because I'm substitute.
Thank you. Are you interested in playing girls soccer? We're hosting an interest meeting during advisement for all students who want to learn more about the plans, schedule, and what it takes to return the team. Meeting is Wednesday, November 19th. Coming to the Benji and Mendel, connect with other players.
Guy, thank you.
No commitment is required.
Yeah, I just bring up your, you brought us in.
Yeah.
Okay, good. Thank you.
Thank
I think
you.
I must be.
Friday, December 20th.
Appreciate it. Thank you.
Kathy Maria, Spark in the Dark Foundation will be speaking. So come join for a powerful story, worship, and fun game.
Have a good one.
Yeah, thank you.
Today's quote is from Theodore Roosevelt. Do what you can with what you have, where you are.